Hello everyone, I am Angie Yurt. I've been building and maintaining Gapminder bubble chart for over a decade now. Today I will show you how to make one of these in under half an hour. So this is Gapminder bubble chart, the classical one. Each circle here represents a country. We have China, we have United States, we have Russia, we have Ireland. Yeah, the size here represents the population, and they are positioned by GDP per capita and life expectancy. Here is a time slider to go back 200 years in time and forward. We'll be making one of these using the library called Observable Plot, and for that we'll need an account in Observable, so go create one if you still don't have it. It's free, and we'll be using the data that Gapminder official bubble chart is also using itself. So this is the official data set that we have. It's stored on GitHub. A GitHub, if you know what that is, it's just a fancy file storage. You can view it that way. So it has files here. They are organized in a data set which has this format called DDF. So this is the format for how to use DDF datasets as a complete package, yeah? But we don't need to use it as a complete package. We'll just grab a couple of files from here. One of the files that we will be needing is this file about the countries. So here we can see our country names. Here are the names, and here will be the regions in the world, yeah, because we want to color the countries by 4 different regions in the continents. And then we will need the actual data points, which are stored in files here. So there's a few of these files. We'll be using this one, GDP per capita. Look how it looks like, country time GDP per capita. Yeah, very simple. We will be also using a file for life expectancy, which has exactly the same structure, and population. And it also has exactly the same structure. So if you need one of these files from GitHub, you can press this raw button here, and it will result in you seeing the actual content of the file through this direct link that you could be using. So by copying this direct link back into our little notebook that we have here, we can get the file. So we'll make a new JavaScript cell for that purpose. And there is a function built into JavaScript that can fetch files on the internet, yeah? So you would do that by calling a fetch function, and you would provide a link to the actual file as a string. Then you get the response, but to actually see the response, you would call then, and then here is your response, and you take it as text, and this is how it would look like. So here is just what we have here is a big, large string of text, and this is not so good because we want these bits parsed as numbers. So to do that, instead of using fetch, we'll be using D3. D3 provides us with a method, d3.csv, that will parse this CSV comma separated values for us, and we don't need this one anymore. And that's how it would look like if we use d3.csv. So that's just a convenience method, so we don't have to do any parsing of the files. However, see how population here is not an actual number because it has quotation marks. Same goes for time. We would rather have them as numbers. For that, we will use d3.autotype as a second parameter in that function, and you can see how now our population became a number and our time also became a number. The time should not strictly be a number, it should be a date object, but as we know our dates are all years, then we can represent them as numbers. No need to overcomplicate that. So this is our first data file that we fetched, and we can call it, for population, we call it population raw. So then we set that to a variable. We will now do the same exact thing 2 more times for life expectancy, that is abbreviated as LEX in the dataset, and I just know that because I'm working with that dataset so many years. But here is a link, direct link for the file, that's why I provided the links here on the top. And we'll make another one, this time for GDP per capita. And we can call it GDP raw, and here we have our GDP values. The final bit that we want to do here is we want to get this file for the countries, so that we have country names and country regions as well. So for that we can use the same approach, except we provide this link to a file now. Yeah. Countries raw, and there's 273 entries in that data table. Okay, at this point we have our data collected from the internet, and now we have it accessible in our observable notebook. At the next stage we will need to join these 4 data tables so that we have our data accessible in one single place for the chart that we will be creating. To do that, we will use Arquero library. Arquero is a really cool and easy library to use in code, and here is I have a link to notebook that's called Data Wrangler, and it's using Arquero with these button pressy tools. Here you can see how you can select, filter, order by. You can do whatever you want with the data, and here is an example of how that code would look like. So it is quite flexible. If you know about pandas in Python, so this is like a similar approach to pandas. So to get started with Arquero, we don't even need to import anything, because Arquero is part of standard library in this observable notebook that we are working with. You type aq.from, that is how you create an Arquero table, and here we'll just pass the first table that we have. So this is how Arquero table looks like. And then to get back from it, you would call objects, and then it converts back to JavaScript array. So this is the exact same result as we had here. Yeah, so this operation doesn't do anything yet, but what we will do now is we will join it to other data tables that we have here as well. For that we will be using join full, and this means the full outer join. In other words, it will join it such that it won't lose any items from any of the data tables. If the item is missing in one of the data tables, then we will still have it in the list. Here we need to create another Arquero table, so aq.from, and then we do our life expectancy table. So see, we have population now and life expectancy, so that's nice. We will then make one more of these for the GDP data that we have. So now we have population, life expectancy, GDP per capita, and finally we will join in our countries. Let's do that. And now we have countries here as well. We can see how the result looks like because we can create a table view here as a special cell in Observable. And here we can see the result for country time. We can see population, life expectancy, GDP per capita. And then we have all these many data columns from the countries table. We don't need so many. We only need to select just a few of those. We take country so that the two tables would have a common column to join them. And then we need a name, and we need world regions. So here we now have only the columns that we are interested in. Here are the 4 regions that we have, and here are the names of the countries. As you can see, the names of the countries repeat now. So for each of them years, you have Afghanistan name that didn't change, and Afghanistan region that didn't change, and the same for all the other countries. If I go all the way and scroll until I get out of Afghanistan into some other country, now I have Angola, and here the name repeats again, and Africa, the region, repeats again. This happens because when you join a lower dimensional table, such as country, so dimension is countries, to a higher dimensional table, such as population here, with dimensionality of country time, then it will fill and repeat all the values until it fills all the rows, if that makes any sense. But if it doesn't, then just don't worry about it. We just fill the same value multiple times in this data table because it doesn't depend on the time dimension. All right, the next step that we want to make is we want to make a simple chart out of this data table. So to do that, we press plus to create a new cell, and we don't press the plus far away, we press it right after this table. And see, then we have a suggestion to create a chart. So we'll press that. And now we have options that we can do. We can also move this now to the desired place that we want to have. And it connects to data 1, which is the output of this data table. We don't really need data 1 because we didn't edit this data table. You could do that, but we just take the data, our original data set. For X, we'll take the GDP. We got a histogram of all the values in GDP. If we customize and set X scale to be logarithmic, then you get like a more reasonable representation of like a GDP distribution between different countries. For Y, we will take life expectancy now, and our bars have turned into little circles because the mark here is set to automatic, and this is a good choice. Yeah, dot is what we really want because dots are the circles and circles are what we use in the bubble chart. For color, we want to use the regions. This is how they look like. And for size, we want to use population. So this is the start of the chart that we want to have. We may also customize a width so that it makes a full, it occupies the full width of the page. And then the height, we can take 600 pixels. And I think that's good enough. So at this point, we want to add more customization to the chart. So we got the basic chart here, but we cannot filter it for only 1 year. Now it shows all the years. So to provide the further customization of this, we will need to escape the limitations of this chart cell that allows us to get started quickly, but then we actually have to use some code. So to do that, you have to press again the plus button straight after the chart. So if we press it here, we don't get the magic suggestion, but if you press it after the chart, then you get the magic suggestion convert to JavaScript. So we do that, and we get exactly the same chart here, except this is how it would be done with code using the plot library. And here is the one that is done with the chart cell. We don't need that one anymore. Let's remove it. So now we're using plot library to create the chart that we wanted. Or not yet what we wanted, but let's edit it until we get the chart that we want. So first of all, this is too many circles. Let's filter them such that we only have circles for the year that we're interested in. Let's add a filter. So filter you can add here among the encodings of the dot mark. So marks, dot, and then we add a filter. Here we need to provide a function, and the simplest function you could have looks like this. So this is the input of the function, and this is the output of the function. This is called the identity function, that meaning that it doesn't do anything. But if we start adding like a condition here, so that we can have f.time should be equal 2023. This is a strict equality in JavaScript. So if it's equal to 2023, then we have a year that is here. If it's equal to 1950, we would have our bubbles here. So you see how we can choose the year by changing this. But we don't want to change it manually, right? So that's the next stage that we have. Add interactive slider for year. This is really easy because Observable Platform provides us many of these interactive elements that we can use, and among them interactive elements we somewhere have like a range slider, but you could also like just type in the search slider and then you get the range one. It's called range, I don't like that, let's call it year. And then it should go from, let's say, 1950 to year 2023, and let's also call it year, like a label. It should have year with capital Y. This is what results in the label here. And now we can change the slider. If we take this value and we just output the value year, we can see how that updates as we change the slider. But then we can use this value year in here. So if we just plug that in here like that, then our bubbles become interactive as we change this time slider. At this point we can remove this we don't need, and we can reposition the slider to be, let's say, above the chart and remove, well, wait for that, above the chart, so it's easier. However, you see how it's at 1950s to 2023. This is called hard-coded values, and we don't really like hard-coded values in coding, because what if the data changes and instead of 2023 there is like 1 year in the future, yeah? So then, well, what must you do? You must go back and change this in the code. And that is not ideal. So it's much better if you make this calculated automatically based on the dataset. To do that, we'll need maximum and minimum years from the dataset. You can see them here. Yeah. So this is the minimum 1800. This is the maximum 2100. So we'll use some functions to find out our minimum and maximum. So if we call D3 minimum on the array of data that we have, and then we provide it with a so-called accessor function so that it would access the column of time. Then we get the minimum value like so. You see 1800. We can also take the maximum value like so, and it says 2100. However, we also have the extend method, which is like a convenience method. it returns both the minimum and the maximum. And you can see how this is an array of 2 elements, which is exactly the same format as we want to have here. So at this point, we can call it something like time span, and we plug that in here. Yeah, time span. And now we have the 1800 to 2100 based on our dataset and not hard-coded by ourselves. And we don't really need to see this, so we can move this far away, somewhere here. Yeah. The order of cells doesn't matter in observable notebooks, so they get executed and they get evaluated in the order that is determined by the notebook, and not in an order that they are positioned here. So you can position them however you like, and they will still work fine. The step here is 1, and that's good, so we can move this by 1 year at a time. However, let's set the initial value to be 2023. So to do that, we set the value, and we set 2023. So that's how this slider will look like when we start the page. And then unpin this cell and collapse it. So now we just have an interactive element, and we can use it like so. Cool. So now we have the chart. Let's add some customizations so that it looks like the actual chart that we have here. First of all, let's use the fill of our circles instead of the stroke. So stroke here is attached to world region. Let's replace that with fill. You can see that it was successful, but now we can't distinguish circles of the same color if they're overlapping. So to fix that, let's return our stroke, but we just set it to a constant color, which will be black. And then see, if I make a mistake here and I forget the comma after each of them properties, then this doesn't work. So I need to remember put the comma after each thing. Now it does work. You can see we got the stroke around each bubble, and it kind of looks very massive stroke. It's taking a lot of attention. So let's make it thinner. For that we can use stroke width, and we just set it to 1 pixel, and now it's much thinner. That's nice. At the next stage, what we want to do, let's increase the bubble sizes so that the bigger bubbles, they're also bigger, like in this chart. To do that, we need to start providing configurations for encodings, and our size encoding here is called R. It's for radius. Yeah, so for R we want to add a configuration, and the part of the configuration we'll be changing is called range. So range should be an array, and then you should set the minimum size of a circle and the maximum size of the circle. Let's go from 1 to maybe 70. Yeah, that's good size circles that we get now. Now it starts looking a little bit similar to this, but the colors are different. So here I've prepared the colors that Gapminder bubble chart is using. Those are exactly the colors here. And let's set manually the palette to follow this scale of our regions. Yeah, so I can select my regions like so, and here in the color we already have the color properties. I would need to modify the domain. That is the input of the scale. It needs to be an array, and I just list my regions in order. The order is important because at the next part we will provide the range, and inside the range we will also have an array which will contain our colors matching those regions in order. So let's take an array. Let's take the colors. Remember to have the quotation marks and the commas in the end. So we got them. What I'm doing here is I'm using multiple cursors to copy and paste different values in my little code editor. So every code editor is capable of using multiple cursors so that you can do things like this, you know, multiple cursors. Pretty cool. And now we don't need this bit anymore. We can remove that. So after we've modified the colors, now our bubble chart seems pretty similar to what we have here. I think also we can set like opacity to 0.8. That's what we're using in the other one. And now it's even more similar. So for the remaining parts, let me see what I wanted to show you here. Oh yeah, we have the tooltips, which now has all these like crazy fields in it. But let's change the tooltip so that it shows us the names of the countries. Yeah, to do that we will just need to add another encoding, and we call it title. Not we call it, it's just called title. And we set it to name. That needs to be a field from the data. Yeah, we have the name here. So now we get the titles as our countries are properly called. Yeah. And finally, I wanted to show you how to create this year in the background. See, it says 2023, and now we don't really see that clearly what kind of year it is supposed to be. So to create the year, we will now we will have to add another mark here. So our marks here at the moment are just dots. So a year would be another mark. We place it before the dot so that it ends up being positioned behind the dots. Yeah. So first a text would be created, and then dots would be created on top of text, and that's how we want it to be. So for the text, we'll need to first provide a data to base the text on, and we only need one element, so we just need the year from here, yeah, from the slider. So that's the same year as here, but this won't work because a year needs to be, or data input needs to be an array. It's easy to convert one value to an array because look, we have one number here, and we can just do this, and now it's an array of one value. Yeah. So if we put it in brackets, in square brackets like that, then we have an array out of a single value that we have. Cool. And then finally, we need to provide some configuration for the mark, and now we list the encodings. The most important encoding we can think of is text, and that would be just copying the value from whatever the data has here. It's not visible anywhere, so let's make it positioned. So let's set x to 1000, so then it should appear somewhere here on this line. You see 1000 of GDP dollars. And then let's set y to maybe 25, so that we get some kind of text visible here. See, like 2040, and then if we change that, the text changes. So now we have a few problems. It's in the wrong place, and it's too little. So to make it larger, we first change the font size. Font size. And I suggest that we set the font size as a fraction of width. So width is a built-in variable in observable, and if we just check what it looks like, it's 1152. Yeah, and if we resize the window here, look, I resized the window, it's still 1152. Now it's 828 because the window got more narrow. And now if I keep resizing the window, this thing updates the width. So this is how we can make a little bit of a responsive layout here. We just take the width, and this is clearly too large, but if we, let's say, divide it by 3, we get some kind of like reasonable, reasonable number size. We can also change our largest radius that we have here. So if we set that to like width divided by, I don't know, 10, that's a bit large circles, but you see how they are dependent now on the size of the screen. Maybe let's divide them by 20. Yeah? Do we like that? $17 maybe. Yeah, that's good enough. So now our circle sizes are also changing as the window changes size. So this is like a little bit of a responsive layout that we've achieved. At this point, we just see a part of the year text 019. So we need to reposition it. To position it, we need to provide its coordinates, and those are in the units of GDP dollars and life expectancy years. So I kind of want to like make a trick here. So for GDP dollars, I can take the maximum number in the dataset, and we do that by calling d3 max, remember, and then we provide accessor function to GDP per capita, and now it's like all the way there. So the middle of that text is now at the maximum value of the scale that we have. And then we can provide delta x, so dx, and that would be just in pixels. So then we can manually shift this label anywhere we like, and let's shift it by minus width divided by 2, and then so the center of the text now in the center of the screen. So this is what I wanted to have, and here it changes with data. I don't like this comma though, so we need to change the text so the comma disappears. Now the text just shows us the number, but if we convert it to string, which we can do by adding an empty string in front of the data number, then we don't have that comma anymore. Now we have converted that to a string of text, and look how it's jumping now when I'm changing the time, and the text is jumping all the time. So all your attention is captured by the jumpingness of the text. To fix that, we need to use a monospace font. A monospace means that each character here would take the exactly same width, and that would prevent the jumpiness. To fix that, we need to add another property here. We set font family, and we can set that to monospace. Yeah, it's like looks a bit nerdy, and you can use custom fonts in observable, but this is like a quick fix to prevent the jumpiness. It's also way too black, so if we set the fill of it to some kind of gray color, I bet CCC looks like gray, then it's less visible. And now let's just position it vertically so that it ends up in the center. We'll use the same trick as we had for X, except we'll use it for Y. Now we'll take the maximum value of life expectancy, and then we position delta y by minus, no, now it's plus because the 0 is like here at the top. So the vertical coordinates, they start from the top and then they go down. So to shift it down, we can do like 300, yeah, and then it ends up here in the middle. Why do I know 300 is the middle? Because I have height the 600. So this should be half of that. Let's fix it nicely. Let's declare a variable, height, set it to 600. Let's use that here. Height equals height, and width equal width, and then height half of it, then it would be the correct position, even if we change the height later. So this kind of notation, you see how width, a property in here, is set to width, a variable that we have in the notebook, and then height is set to height. So when you have situations like this in JavaScript, you can use a shorthand notation. So this is why this also works. This is just the same way to, maybe that's just too much confusion for a start, but this is a shorthand notation that allows you to not to write the same thing twice when they look like the same thing. All right, I think this is it. We have the text, we have the bubbles, we can add some grid lines, so that's really easy. We can just set grid to true for x, and then for y we also set grid to true. Don't forget to put the comma to separate these properties, x and y. And now this is all we need, yeah? So I will put some links in the description of this video. I will put the link to the empty page that you would start with, and I would put the link to this page which I made right now, which would be the solution to the tutorial that we were having. Hey, I'm back already. I forgot to tell you then how to use whatever we've just created on the internet, like on your web page, on your website or blog. So we need a way to embed this chart to your website. I'll show you how to do that now. Here we have our year, so we need this part to embed, and we have a chart. We need this part to embed. We don't need anything else in this notebook. So to embed, we press this thing and say embed here. We can do this on the chart. However, this is now disabled. See, this is disabled. This is a very common blocker. It says like a little tooltip here. Name this cell so that it can be exported. Yeah? Do we have the tooltip now? Yeah. Name this cell to embed. How do we name that? Let's write just chart equals whatever cell we have. Now this becomes available. See? If we press here, we have a chart. This notebook is still private and requires a key. Okay, so we cannot embed a private notebook anywhere else. Yeah, let's press the share. The share button is here. Let's give it like a nice link. Basic use of observable with Gapminder data. F. Yeah, that's enough. And now let's set public to view, yeah, instead of no access. And now we save that. And now if we press embed here, oh, now that actually works. So basic use of observable plot with Gapminder data from a DDF dataset. We can remove this attribution banner if you don't like it. But like, you know, give Observable a credit. They made amazing software here. And I click this view of year. That would allow us to embed the year slider as well. And now if we copy this part, this iframe, we can then paste it to a website. So here I have an example because I'm teaching at the university, and here is my Canvas page. So if I edit my Canvas page here, and then I switch to HTML editor, so this is like regular editor, yeah? And you could have like paragraphs, and you can have a title, which would look like this. For example, yeah, this is a regular editor, but if I switch to HTML, I see a title in H3 tag, and I see paragraph in P tag. So this is what we need. We just insert that iframe that we got from here, and then it just sits like that here. And then you can leave this HTML editor if it's like scary, yeah, you can leave that, and it will remain here. Cool. So now if we save that page, I have the page and the chart running in Canvas, and it is fully interactive. So this is how I could use my chart on the website or blog or whatever. This is just a Canvas page in the university teaching website. So this is it. Thank you. Bye bye now.